between two parallel current carrying conductors. Very easy, students, because instead of a single wire we are taking a two wires. This is the wire AB carrying a current I1 in the upward direction, south to north direction. This is the wire CD, long straight wire CD, which carrying a current I2 from south to north direction. Both are in the same direction. So there will be a magnetic field B1. The magnetic field B1 will be created because it is in the by the right hand thumb rule. So it is anti-clockwise direction. B1 will be act on the wire I2, which carrying a current I2. Also, this current I2 produces the magnetic field B2. This B2 will be This B2 will be applied on the current carrying wire I1. So very simple, it is a mutual. This magnetic field, the magnetic field produced by the first wire will be applied on second wire. Then the magnetic field produced by the second wire will applied on the first wire. So we come to the conclusion, a current carrying conductor placed in a magnetic field for both the wires. So both the wires will experience force according to the Fleming's left hand rule. This is the direction of the current. This is the magnetic field. Then what will happen? The magnetic field direction is like this. So the magnetic field is here. The force will be acting towards this direction, and also here the current direction is upward direction. The magnetic field will be in the anti-clockwise. So the magnetic field direction is in this direction. The force will be perpendicular towards this one. So this is a F2, this is F1. Now we are going to calculate what is a F1 and F2 expression. So magnetic field produced by the current 1 at any point on CD. The magnetic field produced by the current I1 on CD, any point on the CD. This B1 expression is mu naught I 2 pi R. This I is a 1. This is a magnetic field 1. Similarly, we can write B2, which is equal to mu naught I2 by 2 pi R, because the R is a distance between the two parallel wires. The force on the length L of wire CD is, so what is the force experienced by the wire CD due to the magnetic field B1 produced by the current I1? So that is F is equal to ILB sin theta. That I is a current I2 and B is a magnetic field produced by the first wire. So ILB sin theta, I2 B1. So I2 as it is, L that is for B1, sin is a 90 degree. How we can say that the current and magnetic field are perpendicular? The angle between the I2 and B. So the I2 is going in this direction. This B1 is in the perpendicular. Both are by the Fleming's left hand rule. This is in the perpendicular direction. Sin 90 degree. Sin 90 value 1. You substitute this B1 value here. Mu naught I1 2 pi R. So finally we come to the conclusion. Mu naught I1 I2 L by 2 pi R is a force experienced by the current carrying wire CD due to the magnetic field produced by the current carrying wire I1, that is a AB. So this is a force. So what is the force per unit length? This L will come to the denominator. That is the force experienced per unit length is mu naught I1 I2 by 2 pi R. Similarly, we can derive the same expression for B2 is equal to mu naught I2 by 2 pi R. For that means magnetic field produced by the second wire current, that is current I2, magnetic field is B2. Here the F1, here I1, B2, the same substitution. So similarly, an equal force exerted on the wire AB due to the magnetic field produced by CD. So both will be F1 is equal and opposite to the F2. Both the forces are equal and opposite. If the parallel currents are going, there will be attractive force. If the anti-parallel currents are going, it will be a repulsive force. So if both the currents are going in the same direction, the force will be attractive force. If it is the anti-parallel direction, that is a repulsive force. So generally we can write that force between the two parallel wires is F is equal to mu naught I1 I2 by 2 pi R. Simply if you know the current value I1 and I2 and the gap between these two, we are able to calculate the force between the two current carrying wires is mu naught I1 I2 by 2 pi R. So very simple, students. It is a practical application of what we are learned in the previous session force on a current carrying conductor in a magnetic field. So here the magnetic, no external magnetic field is applied. The first wire magnetic field will be applied on second wire. Here the second wire magnetic field is applied on first wire. There will be a mutual force. Both the mutual force are equal and opposite. If the current are in the same direction, attractive force. If the current are in the opposite direction, repulsive force. So that is given here. Okay. Thank you, students.